All right. So welcome, gentlemen. I'm glad to see everyone here, and you guys are hanging in there, doing what you need to do. I haven't really checked your grades on Pearson or anything. It's just there, right? Just let me see. Just kind of like to recap and some announcements. So this is like the top of week 6. We can expect exam 2 during week 8. Exam 2, you can expect something similar to exam 1. The only difference is I want to schedule for each student like maybe a 15 to 20-minute window where it's an oral component to the exam. Make sure you guys can hear me. Testing, testing. That looks good. Ali Ali Oxenfree, that looks good. Um, and that's just about let him in. And for that component, the main thing I need on your end, I just need to be able to see your face. You tell me what to write. I'll be showing my screen like we do each session. I guess I need to keep this open. Yeah, you just tell me what to write, and we'll kind of go like that, and not, just a few questions, just like 3 questions, 3 or 4, something like that. But it'd be similar to otherwise the other stuff, and like I don't want that to be more than 20% of that grade. Uh, so all of our homework for the semester is available. All of our quizzes for the semester are available. The only thing, like, the exams aren't, right? And so like the homework and quizzes, I had students still asking for like extensions. I was like, I don't know. I'm just saying. I'm just kind of repeating some of the stuff I told them. I'm sharing it with you all. Is that there's a natural extension built into the way I have it set up. Even though on a weekly basis, our assignments for each week are due Monday mornings at 9 a.m. You can actually work on any assignment past the deadline with only a 10% late penalty. So there's a natural extension system built into the way I have everything set up. Um, I mean, even quizzes and exams, you can still work on and improve your score. So if you made below a 90 and you want a 90, you just keep taking it until you get that score. And I would recommend, if you are just trying to improve your score, like, the main thing is you want to make sure your exams are in order, because you're between the 3 exams that we do together and then your final. There's 4 exams. Those 4 exams make up about 80% of your grade. So at any moment in time, if you ever need to know what to focus on to improve if you're just blatantly trying to improve your score, exams, you want to make sure those are in order first. And then after the exams, um, you can work on your quizzes, make sure those are in order. Because the quizzes, even though the quizzes are only like 5 questions each, and so that's a lot less work than the homework, and it's the same weight. So where the homework are a lot of questions and it eats up a lot of time, and it's not that many points, right? So the homework is really there for you to get practice, for you to get familiar and learn, learn the ropes or whatever. But then to show what you know, that's where the exam comes into play. WH, trying not to. I keep wanting to say you guys' name, but I'm aware that I'm streaming, so I try not to. I think I let him in. Yeah. So what I've been doing. So let me see. Exam 2 is approaching. Again, we're at the top of week 6. Exam 2 will be during week 8. So I know we finished the lectures, like the presentations that I wanted for 1.4, 1.5, and 1.6. So what I've been doing is going through like the homework questions. Now today I'm still kind of working on section 1.6. We don't have to stay in section 1.6. That's just where I left off, and I'm just going through the questions. And it's generally a different set of questions with each group. So if you want a complete like presentation, like if you want all the questions, you have to go through to the other sessions with my other students. And those questions, oh, I gotta reboot this. Those questions are available on my YouTube, right? Um, so our Blackboard page is like the central hub for everything. So if you're ever trying to find, oh, I didn't make one for you all. Okay, let me make one right now. Did I change that thing? It's too late now. I'll change it later. Um, let me do this. Let me go to edit. Come on, quick. Copy. And then I just want a new one. Yeah, that's better. And then paste. Okay. And this is the 3 p.m. I don't know if I changed that thing or not. I think I did. I'll check it later. Okay. Yeah, so obviously we don't have enough meeting time to go through all the questions in one session. So that's why I stream the sessions with the other students. So that way, whatever we're not able to do together, I usually do it with another group, and I make it available for all of my students. There was something else. Okay, anything important was just gonna pop back up. And so yeah, I'm gonna keep working through section 1.6. If you would like me to go through another question, I'm gonna go ahead and suppress my audio. Just get my attention. So like either type in the chat or raise your virtual hand, and I'll see it. Like I'll get a notification and it'll get my attention and I'll check it, and we could talk about it. There is something in the chat. Let me check the chat real quick. So my YouTube is Beautiful Mind Pfeiffer, or you can just go to our Blackboard page, and I'll put a link there as well. Our Blackboard page has everything, right? It has anything that you see me writing, like doing handwritten. I load a PDF on our Blackboard page. You can actually access the homework through Blackboard. There's a link for my YouTube and Blackboard. Everything is on our Blackboard page, right? So if you're looking for anything associated with our group, it's on our Blackboard page. Okay, I know I keep saying I'm not, but I don't know. That's just I don't care. I know I shouldn't because I'm streaming, but I'll get over that sooner or later. So where I left off, let me see. Yeah, let's work on this one. So with my previous group, I was working on question 12, and honestly, I mean, it took me a while just because I was trying to go through all the nuances and details. Once you get it, it should go a little bit faster than the way I was doing it, but I was kind of intentionally trying to take my time and like give you the stuff I felt like you needed to hear, or say the things I felt like I needed to say regarding this concept. And I'm probably going to repeat some of this stuff with you all since we're kind of still working on a similar concept. So let me take some notes before we hop over to the tablet. This is question number 13. This comes from section 1.6, 35. And like another thing I'm doing is like, I don't want to move into chapter 2 just yet. I'm trying to save that for after exam 2. So I'm trying to like, let's just focus on 1.4, 1.5, and 1.6. I might go back to some previous sections if needed or requested, but I'm trying to keep everything to chapter 1 for right now. So we have this section 1. This is question 13. It comes from section 1.6, question 35. It's like it has 8 parts. Okay, it says let f of x, I'm just taking some notes. We got f of x equals 9x squared. And then we have g of x equals 4 times the square root of x. All right. Find each composite function and describe the resulting domain. Find each composite function and find, I don't know what I'm writing there, and find each corresponding domain, okay? And then for part A, we're going to hop over to the tablet momentarily. For part A, it asks us to find F compose G. For part B, it asks us to find G compose F. For part C, it asks us to find F compose F. And part D asks us to find G compose G. Hopefully you guys are making your way through the lab okay. You've connected with Dr. Lamar and you were able to kind of like figure out what you need to be doing for that. She'll give me an update of what you guys have been doing, and I use that to process your lab grade, right? Yeah. So just do the things that she asks you to do, and that's kind of how that goes. Okay, so let's hop over to the tablet and see the notes that I took. Let's go here, like this. Let me check the stream. Ali oxen-free, that looks good. That looks healthy. Okay, cool. So these are the notes. We have these two functions. So let's start with part A. Part A asks us to find F compose G, all right? So again, what does this mean? This means the following. This symbol, again, this symbol, oftentimes students confuse it. Give me a moment. H. Oftentimes students confuse this symbol and they think it's multiplication. This symbol does not mean multiplication. This symbol means the second function inside the first function. So f of, I'm going to do G in green. F of G of x, right? The second function inside the first function, right? So this is going to be f of the second function is 4 times the square root of x, right? 4 times the square root of x. So what we're going to do, we're going to write the function f like normal. We're going to replace each x with a blank set of parentheses, and then the green thing is going to go into each blank parentheses. So f of x is 9x squared, so this is going to be equal to 9x squared, right? We replace each x with the blank parentheses, and then we're going to put the green thing, in this case, into the blank parentheses. Okay? So now if we simplify, which is going to bring the 9 down or over, 4 squared is 16. The square root of x squared, they're going to cancel. So it's just going to be x. We might need absolute value. Let me think about it. I think this is fine for now. I'm going to leave it like this for now. Okay. So 90 plus 54, what is that, 144? I think I'm going to, let me check. Let me put in my calculator real quick. It should be 144. 9 times 16. Okay, cool. Okay. So this is 144x, right? So that's what I call the simplified function. Now I think also it asks us to find the domain of each of these, right? Find the domain. So now when I find the domain of a composite function, there's a 3-step process that I do. I'm going to say domain of composite. I'm going to shorthand it function. Function. All right. The domain. The first thing that I like to do, I want to find the domain of the inside function. Second thing I like to do is find the domain of the simplified function. And then the third thing is take their intersection. All right. So let's do this 3-step process. The first one, the domain of the inside function. Okay. In this case, the inside function is g of x equal to 4 times the square root of x. So the only restriction there is, do you remember us saying something before about taking the square root of something? What is it about square root? All right. We cannot take the square root of what kind of numbers? We cannot take the square root of what kind of numbers? We cannot take the square root of negative numbers, all right? So the only restriction for G is that radicand, that inside part, which is here, this radicand has to be greater than or equal to 0. So then we'll say the domain of G of x is that x has to be greater than or equal to 0. So in interval notation, that's going to go from 0 to positive infinity. And in this case, the 0 gets a square bracket because x can be equal to 0. The difference between square bracket versus parentheses. Parentheses mean we get really, really close to a number, but we don't ever reach that number. We don't include that number itself. Square brackets means we get really, really close to a number, and we do include that number. All right. So we can take the square root of 0, so that's why we use equal to 0. Math oftentimes is this discussion around closeness. What happens at a value and what happens when you're really, 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 really close to a number. Sometimes when you're really close, those numbers work, but exactly on the money, sometimes the number doesn't work, right? So we're not only concerned with what happens exactly at a number, but we're having a discussion about if you get infinitesimally close, like really, really close to a number, what happens? Like, does the same thing happen? All right. And then it's constantly this discussion about closeness. Constantly this discussion about closeness in math, right? Okay, so that's the domain of G. And just for the sake of space, I'm actually I'm gonna move this stuff around a little bit. Like this, and I just want to move this like here. Come on. Cool. And I'm gonna separate those. The domain of G, I'm just gonna separate them like this. All right. Hopefully that's not too much. I don't like that. I don't like it. I'm gonna just space it out some more. Okay, that's better. Okay, and then let's do it like this. I'm gonna move this here, and I'm gonna put is. Okay. All right, so we talked about the domain and inside function. So then the next step is we want to find the domain of the simplified function. So we want to find the domain of the simplified function. All right, domain of the simplified function. So in this case, the simplified function that we got, let me see the time. Because these questions are like, I mean, we have the time, so that's kind of why I'm taking my time. You know, we have a lot of time. So, oh, the other thing I wanted to mention earlier that I couldn't remember. So again, I just wanted to also remind you all that the way I have everything is set up is for really, I intend for the class time, like this time right now, I really wanted to be like a study session or a Q&A. I would prefer that you all came with questions, but you're not required to. I just really just want you to check in so you connect and I know that you're okay. Because what I experienced in the past is like when I did asynchronous and I didn't have you guys check in, I wouldn't hear from students for like extended periods of time. And most students were okay, but every now and then some students were not okay. And at least that little check-in is enough to me, like, okay, wait, I haven't seen this person. Let me go looking for them. Are they okay? You know, just trying to keep a little bit of a human element to this remote thing as much as I can. But yeah, but the original intent for this time period is really, for the way I have it set up, is for it to be Q&A. But again, it's not required. So that's why I go through the homework questions. So I just wanted to remind you of that. Okay, so let's look at, so the domain of the simplifier, right? We have this expression 144 times x, right? If we had y equals 144x, that's just going to be a diagonal line with a slope of 144, right? So it has a positive slope. So because it has a positive slope, the domain of a line is going to be all rails, right? So we could say the domain of simplified function is all rails. Negative infinity, let's fix that. Negative infinity to infinity and beyond, right? So then the third step we found the domain of a composite function is we want to take the intersection of the first two. All right. So the third step, we want to take their intersection. Okay. So then the first part, we got a domain of 0 to infinity, like this with the square bracket. We want to take their intersection. We want to intersect that with the second result we got was all reals, the whole number line. Right? So we have this half interval intersection, the whole number line. So a half, the green intersect the black. What do you think is the result? The green is half the line. The black is the whole line. What do they have in common? They both have the green thing in common in this case. So the half interval intersect the whole number line is going to be the half interval. Because both of these sets have these points in common. So this ends up being the domain of the composite function again. So when I find the domain of a composite function, again, there's this 3-step process that I usually do. Domain of the inside function, domain of the simplified function, and then we take the intersection of those two results. Okay. Let me see the time. Okay, we're good on time. Let's keep going. So I'll plug these into Pearson. Let me at least do the first one because I think that saves it for us. Because I was able to leave it last time and come back and it was the same number. So let me at least check these. We got 144. Let's hop over to Pearson. Like I think it's this one. That looks good there. So for F composed G, we got a result of 144x. 144x. And look at God. Okay. The domain of this function we got was the half interval 0 to infinity. So now if you put the wrong grouping symbol, these grouping symbols are important and it's very subtle. It takes some getting used to these concepts. It takes some time getting used to these concepts, or effort and focus, because they're very subtle and it's very easy to like overlook them, but they have different meanings. So it's not just random grouping symbols, they have meanings, right? Parentheses means generally we get close to that number, but we don't reach it. So that's why infinity always gets a parentheses, because we never reach infinity, right? You know, sometimes I play in my mind though. I'm like, okay, even though we don't reach infinity, is there a way that we can like capture infinity? You know, like even though we don't reach it, but like does it go so far that it loops back on itself somehow, you know? And like there are different, man, I'm telling you, like the concepts in math, they just do not stop, because there are different kinds of infinity. Right? You know, like we all get the concept that infinity goes on forever, but you know, like one concept is like, can you say that one infinity is larger than another? Like, what does that mean for one infinity to be larger than another? And for instance, like, so that brings us to this notion. It's called like a countable set versus an uncountable set. Like you have some sets, even though they're infinite, you can, if you could count forever, you actually could count all the components, right? If you can count forever. Another type of set that's uncountable is so many entry points that you can't even begin to count. Like once you start at the first number, you can't even begin to count the second number. It's so dense. Like it's so many results, right? And then apparently there are higher versions of that. Like it just doesn't keep going. It doesn't stop. It just keeps going, right? Like, and that's just the concept of counting and concepts of infinity. If you go on YouTube and put a like number file, they have a bunch of like really interesting, quirky videos. Another one is like Google, and like describing how big, like what's the biggest number you can think of, and like can you make a bigger number? And it's called like a Googleplex, and it's like it's so massive. If you like had one particle of matter for each digit in this number, there aren't enough atoms in this universe to write out that number. That's how massive it is. It's something like that. Like the number is so big. I was I was about to make an inappropriate joke, but it's just interesting. It's just interesting, fun stuff. There's another one. I wanted to mention. So I found myself on the weekend. I came again. I just Sundays and YouTube's just be like, I just get sucked into the rabbit hole, and so I came across somebody was kind of repackaging a lot of paradoxes I've heard before, and not to eat up too much time, but like for instance, like consider a pile of sand, right? You just take some sand and you pour. You have a pile of sand, right? If you remove a grain of sand, is it still considered a pile? You would say yeah. Suppose you remove another grain, you would say yeah. At what point, how many grains of sand, like at what point does it stop being a pile? Like if you have 1,000 grains of sand, is that still considered a pile? If you have 100 grains of sand, is that still a pile? If you have 10, is that a pile? If you have 2, is that a pile? You see what I'm saying? And like at what point does it become a pile of sand? I mean, and like that's just a paradox, or because you wouldn't say that 2 grains of sand is a pile of sand. You wouldn't say that. You know what I mean? It's funky stuff like that. I call them stoner questions. It's kind of trippy. And there's some other ones. They're paradoxes and just fun stuff. Anyway, let's get back on task because I can just talk and just talk and talk and talk and talk and talk, and I won't stop. I had to intentionally make myself stop. Okay, so we got these results. I think we submitted them because I just wanted to save those. So let's go ahead and start working on the next set. Let me see. Let's do at least one because this stuff does kind of take a little bit of time. And again, I'm just kind of eating up time intentionally because we have time. Come on, there it is. Okay, so let's go ahead and do part B. Part B asks us to do the reverse, right? So we did F compose G. Now let's see what happens if we reverse the order, right? If we change the order, does that change our outcome? So then part B asks us to do G compose F, right? Let me see in the chat. Nothing's in the chat. Okay. G compose F. Let me give myself a little bit of space. Okay, this means, again, this means the second function inside the first function. So we're going to have G of, I'm going to do F in orange, G of F of X, right? Second function inside the first function. So this is going to be G of F of X is 9x squared. So it's going to be G of 9x squared. So what we're doing is we're writing G like normal. Let me look at G really quickly. It's 4 times the square root of x. I got enough space. So we're writing G like normal. 4 times the square root of x. Generally what I do is first thing is I replace each x with a blank parentheses. And in this case, 4 times the square root of x. Yeah. And then we replace each x with the orange thing in this case. So 9x squared, right? So then we want to simplify. This is going to be equal to square root of 9 is 3. I feel like, okay, if you want to be technical, the square root of x squared should be absolute value of x. But I think for this context, we're not going to do all that. I'm going to leave it as 4 times 3 times x. All right, because the square root and the x squared cancel each other. Okay. So then this gives us a final simplified result of 12x. Okay. So that's our simplified result. So then next we're asked to find the domain. So I'm going to say domain of composite function. Do you guys know how to write in cursive? I'm just curious. Because I know that that's not like one of those things that's, we don't really do that. Everything is digital now. I know that's one of those things that's being lost. And sometimes I just write in cursive just for the sake of doing it. But, I don't know what kind of like stuff it does to the body and the mind. How does it improve it? Does it improve it? Like there are some things there, I feel like. But anyway. So the first thing is what? So to find the domain of a composite function, again, a three-step process. The first thing I recommend is we want to find the domain of the inside function. Inside function, right? The inside function in this case was the f of x at 9x squared. That's going to be a U-shaped graph that's been stretched vertically by a factor of 9. So it's just basically tall and skinny with the vertex at the origin. So if we have a U-shaped graph that's tall and skinny with the vertex at the origin, what's the domain of this? Well, the domain there is going to be all reals because it's a parabola. Let me do it like this. All right. So the domain there, the domain of the inside function in this case is going to be all reals. The second step, we want to find the domain of the simplified function. Okay. The simplified in this case is the 12x. So that's just going to be a diagonal line with a positive slope of 12. That domain is all reals. So I'm just going to copy and paste. Copy, paste. Style black. Right there. Okay. And then the third step that we want to do is take their intersection. Right? So the first set, a set intersect itself is itself. Okay, so again, we got lucky with this one that it was simple. Some of these, get kind of kooky kind of fast as far as finding the domain. I was kind of hoping we would have an interesting one, but it hasn't happened yet. Okay, so I'm going to keep going. That was part B. Let's go ahead and do part C. Part C asks us to find F compose F. All right. F compose F. This means the second function inside the first function. The second function, I'm going to do the second function in orange, which is f of x. Sorry, F compose F. And again, this means this. Second function inside the first, right? So then this is going to be f of, now the second function is what, 9x squared? So what we're doing is we're taking the regular function f of x and we're replacing each x with the orange thing. We're replacing each x with the orange thing. So this is going to be 9 times x squared. And the first thing I do is replace the x with a blank set of parentheses. Then what goes inside the blank parentheses? The orange thing. Okay. Hmm. 729. So if we expand this out, I think we get I think it's 729. Let's see. I'm like, I don't know why. I'm just getting sleepy. Let's do it like this. This, nope. This times this times this. 729. Okay. So we get 729 x to the power of 4, right? So this is our simplified function. Notice I'm showing all my work. I'm putting my final answer in a box. These are habits you want to just do. You want to have when you're working these. Because you can see, you see all the necessary support and work, and then your final answer jumps off the page. It's clear what the final result is. And then let's go ahead and find the domain. And let me just copy and paste. Like I'm going to copy all of this. Copy, paste. So the domain of the composite function. Let's just move it down. Yeah, I think we can fit it here. Okay. Hang on. Give me just a moment. Put that there. I'm just resizing this to get it on one line, just to be using my space a little bit more economically. I'm sure there's a better way to say what I just said, but okay. There's that. Then I'm going to put this back. Okay, that's better. Okay, so the inside function here is what? F of x. F of x equals 9x squared. It's just a U-shaped graph that's tall and skinny. I think we did that one earlier. So I'm just going to copy and paste. Copy, paste. Okay. The simplified function in this case is 729x to the power of 4. That's a power function. A power 4 function generally is like a w, but if it's a power function, it kind of flattens out in the middle. So the shape of the graph is like a wide U almost, and they both go positive. But that domain is going to be all reals. Every x is going to be accounted for. So the rest of this is going to be similar to the previous. These are not interesting examples as far as the domain. We just kind of gotten lucky with these. Let's copy and paste. So it's kind of like the same from the previous, right? I'm hoping that we can get to an interesting example. It doesn't look like we're going to get to one today. That was part C. Let me go ahead and finish out part D. Part D asks us to find G compose G. Okay. G compose G, right? So this means second function inside the first, so G of x. And again, this means this, right? So then what's G of x? G of x is what? 4 times the square root of x. So this is going to be G of 4 times the square root of x. Okay. I think I can fit it. But this is going to be 4 times the square root of 4 times the square root of x, right? I just replace each x with the green thing. Each x in G with the green thing, okay? Okay, so we can do some simplifying. Square root of 4 is 2, so then 2 times 4 is 8. And then, let me see, that's to a half to a half. You multiply, so a quarter. I'm tempted to do, we could probably either leave it as the square root of the square root of x, but I'm tempted to write it as the fourth root of x. Okay. I'm going to go with this. If this is wrong, then I'll make an adjustment. This is what I see. But we'll adjust it if it's not correct. And then for the 3-step process for the domain, I'm going to get a copy of the notes, copy, paste. Okay. So the inside function is g of x. That domain is, again, we can't take the square root. We can't take an even root of a negative number. So the domain of the inside function, x has to be greater than or equal to 0. So we're going to say it goes from 0 to positive infinity. And because we can take the square root of 0, we put a square bracket. If we look at the simplified function, we have the fourth root of x. Again, we can't take the even root of negative numbers, so it's kind of the same argument. That inside part has to be non-negative. So that's going to be this. And then for the final step, we said a set intersection itself is itself. Okay. Yeah, that one was a little bit more interesting because it's a little different. Just a little, but I think we've done one similar already. Okay. I think that was it. Not that one. That's D. So let me just check these results in Pearson. Let me go to paper. Put this back. Okay, so we left off. We left off on B. Let's go to Pearson, and this will be it for the day for you guys. So g of f of x, we got what, 12x. 12x. Absolute value. Okay, so we do need, so that needs to be absolute value. Okay, so let me give a little backstory there. Okay. Let's hop back over to the tablet. So for part B, right? We got 12x. Now we had the square root. At one point we had the square root of x squared, right? So whenever you're doing like square root of x squared, it's like it forces the outcome to be positive. Because think about it. Say you did the square root of -1 squared. If you square a negative, it becomes positive. So it forces the one to go from -1 to +1. So that's why the result there was absolute value. All right. And it just depends on what the order in which you do it. Like if the squared is on the inside, you generally got to finish the absolute value. If that square was outside, then you remember you still can't take the even root of a negative number. So okay, so we made a change there. Let's hop back over here. Let me see. The domain of G compose F. I think the domain stays the same. All rows. INF, right? Okay, we're just about done. Part C, we got 729x to the power of 4, 729x to the power of 4, and then the domain, again, we got all reals, negative infinity to positive infinity. Okay, and then for part D, we got 8 times the square root of 4x, 8 maybe it's not square root. Let me see if I do in root. There it is. So the 4th root of x. Let's see if this works. Cool. And then the domain we got was 0 to infinity. Square bracket. So square bracket is 0 to INF. Okay. Okay. So we made it through that one. I know it took class time, but you know, it's okay. That's the nature of these things. I'm gonna go ahead and make a copy of this document that I was writing on. I'm gonna go ahead and make it available. If there aren't any burning questions, we're gonna end the session here. From one beautiful mind to another. Enjoy the rest of your day. Peace, guys. I'll see you Wednesday.